All right, so this video talks about the law of sines. And kind of the big picture behind law of sines is we're solving a triangle. It could either be a particular side or angle, or it could be all sides and angles. But the key is that I'm not dealing with a right triangle, because normally when we have right triangles, we have Pythagorean theorem, and the phrase that often a lot of people use is SOHCAHTOA. And that only applies if we're dealing with right triangles. You'll notice here in number 1, you'll look at triangle ABC. Notice it has a 104-degree angle. So this is what we call a scalene triangle, and we still have to find some missing information here. So we have to find side AB. So I'll go ahead and highlight there. So side AB is right here. Okay. And another thing I like to do is I like to label all the sides. So notice how the angle A is over here. Okay, angle A is over there. And the angle opens up to the side that it belongs to. So angle A opens up to side A, which is 7 miles there. Okay. So that's what angle A does. So angle B, if you look at it, angle B opens up to the very long side there, so B. It's not necessarily the hypotenuse, okay? But side, so angle B opens up to side B, and angle C opens to side C over here. And you'll notice that on all the angles, they use capital letters, and for the sides, they use lowercase letters, okay? And that's important when I write this next thing here. So, again, it's not a right triangle. How do I find side AB? And even if I could use Pythagorean theorem, I'd have to know two sides of the triangle. But again, I can't use Pythagorean theorem because it's not a right triangle. So the Egyptians were the first ones to kind of ideate this. And then as time has gone on, they simplified it to this. So they discovered that sine of an angle in a triangle over its side is proportionate to sine of another angle in the triangle over that side. And this is true for all the angles and sides in the triangle. So sine of angle A over side A is equal to or proportionate to sine of angle B compared to its side B is proportionate to sine of angle C over side C. Because think about it. If 104 degrees here, if this were to get bigger, let's say it was 110 degrees, side B would also get bigger. Okay? So the sides and angles are proportionate to each other. All right, that's the first thing we need to know. Second thing we need to know. I know some of you are looking at this might be saying, gosh, I have to use all three of these at the same time? That sounds confusing. Well, when we use the law of sines, again, that's what it's called, law of sines. You could have told by the worksheet, that we only need 2 of the 3 ratios. We don't have to use all 3. We only need to use 2 of them. But one of the ratios we do use, we have to know the angle and its side. So the angle and its side that it goes with. So here, so angle C, we don't know side C. Angle B, but we don't know side B. Angle A, we don't know angle A, but we do know side A. So if I could find angle A, that would be great. Well, even though it's not a right triangle, we do know a theory about triangles that all the angles inside of a right triangle add together to equal 180 degrees. So that means if I add 55 and 104, which is 159, and subtract 159 from 180, I should get an answer of 21 degrees. Okay? So that missing angle is 21 degrees. And again, all the angles inside of a triangle equal 21 degrees. And now that I know that I have angle A and side A, I can set up my proportion, which starts off as sine of 21 degrees over 7 is going to be equal to, again, in this case, you can choose either B or C. Let's go with B. So sine of angle B is 104. So sine of 104 over side B, which we don't know yet. And that's what we're going to find. Now, depending on what kind of calculator you have, you may be able to just do it as is, but Mr. Schwann is going to change sine of 21 and sine of 104 into decimals, and with trig functions, we'll always extend it out to 4 decimal places. So, sine of 21 degrees, making sure my calculator's in degrees, I have 0.358 4, if I round, over 7, equals sine of 104 is 0.9703 over b. And then to solve, I cross multiply. So I get 0.3584b equals 0.9703 times 7 gives me 6.7921. And then to get b by itself, we divide by 0.3584, which is going to give me b equals 18.9, but the 9.5 rounds it up to 0, so really Mr. Schwant's going to write 19. That's going to give me 19. Okay, so that's our missing side. Now, before you start saying, well, duh, I know how to find the other missing side, Pythagorean theorem. We can't use Pythagorean theorem because it's not a right triangle, remember? So how do I find that third missing side? Well, I do the law of sines all over again. Okay, but now I have options because not only do I know angle A and side A, I now know angle B and side B. So just to kind of prove the theory, we'll do angle B, so sine of 104 over 19 equals, and this time we need to find side C, so we need to do sine of 55, which is angle C over C. All right, as we know, sine of 104 is 0.9703 over 19. Sine of 55 is 0.8192 over C. We will cross multiply. So it would be 0.9703C equals 0.8192 times 19 is 15.5648. To get C by itself, we divide by 9703. All right, and that's going to give me side C equaling 16.04, which 16.044 keeps the 0 there, so I'll just write 16. All right, so side C equals 16. All right, and that's how you use the law of sines. Again, we found all the missing sides. I know the instructions only said to find AB, which we could have found, okay, which is 16. But I wanted to show you how to do it with all of it. And so just make sure you find the indicated measure, and that's how you use the law of sines.